be able to figure the number of people that are outside that don't belong to any circle, and you should be able to figure out the total number of people that are involved. If you know those 5 pieces of information, then you can answer any question involving a Venn diagram. Now, some of those have symbolic representations, some of those have name representations. So in other words here, I want you to combine A and B, so this particular set is asking me to deal with the 2 circles combined. This information down here says it must be in A, that it cannot be in B. In other words, that means it's in A only. This notation says it's in B, but it's not in A, which means it's in B only. So this would be B only. This would be A only. And this says it's in neither A nor B. So that's another way to be able to talk about the outside section. And inside section in here would be both. And that would be where we would see A and B at the same time. So if you get bogged down into words in exercises and symbols in exercises, sometimes people don't correlate the symbolism that you're going to see to the words that go along with it. So there's kind of a way to be able to attack the problem. Now, in that particular case, now we're going to come back and start looking at the numbers involved in the problems. I'll give you a couple of seconds to get that down if you're trying to recopy what that means, but then I'm going to erase all that and we're actually going to come back and start dealing with the problem as it should be dealt with. In any Venn diagram exercise that you deal with, the most useful piece of information is the section that involves both. Because that's part of each of the individual circles. And since it's a part of each individual circle, then that means that since a circle is composed of 2 parts, that we're going to not do rocket science. We're going to be able to figure out what's present by doing a bunch of simple addition subtraction problems. So up here, I'll get rid of all this. I'll go back and we'll start from scratch. How do you read this piece of information? The number of elements that belong to circle A is 30. Circle A holds 30 items. With that piece of information alone, do you have any idea of where those 30 items are? Do you have any idea if they're in the left-hand portion of that sector or if they're in the football shape of that sector? Then that by itself is not enough information. Here's a suggestion. Do not write 30 in that circle. Because visually, if you write 30 there, you're going to think that it's 30 that are in this piece over here. And that's an assumption that's not warranted. If you have the entire contents of a circle, the smartest thing for you to do would be to identify the contents on the outside. It's the entire circle. Your best outcome is going to be able to know what the left-hand piece of that circle is and what the right-hand piece of that circle is. So does this do you much more good in the problem? Not particularly, because you simply know that there are 50 that are in this part of the circle. But what's really important for you is this piece of information, which talks about being in both of the circles at the same time, which means from a symbolic standpoint, we're looking for that. An and statement is an intersection. It looks for the items that are shared elements. So we just found out that there are 15 elements, whether they're numbers, people, cars, whatever, that belong to both of those circles at the same time. Can you see why that might be a useful piece of information? It's a part of the whole. So that's a part of the whole circle A, which we know contains 30 items. Should we be able to find out the items that are in A only?
Yes.
That would mean that somewhere along the line, we're going to come back and say if there are 30 items altogether in A and 15 that are in both, then there must be 15 items that are in A only. A only is the left-hand crescent of that circle. And if that worked well, then wouldn't we be also able to use the 50 in the circle B? Of the 50 that are here, we already know where 15 are, leaving us 35 items that are in B only. And the number of items that are in the universal set, there's 125 people altogether. I said that there were 5 pieces to every 2-circle Venn diagram. The 5 pieces are all 4 of the individual pieces inside added together. We don't know what's outside the circle yet. But we have all the ingredients we need to be able to find out what items in that circle belong to neither or to none, one of the two. So if we have 125 items altogether, and we've already accounted for the 15 in the far left-hand crescent, the 15 in the football shape in the middle, and the 35 on the outside, then we should be able to find out what's missing by doing a straightforward subtraction problem, and it's not rocket science. It doesn't require brain surgery. It just requires a different focus on how to attack the problems. And a calculator if we can't do the work in our head. So we have 30 plus 35, which gives us 65 out of that 125, which means that we've come up with 65 that are in this section out here. Now there's no elegant place to put that 65. I usually put it in the bottom left-hand corner simply because it's opposite of where the universal set is starting the problem. Now I have all pieces of information. I have all 5 pieces of information that I need. Now there's no question that I cannot answer the problem. I just have to read the symbolism. A united with B. A and B combined. Not good to add 50 and 30. Why? Because part in the middle belongs to both of them. So if you add just the outside, if you add just the gross circles, you double count. These items are in the middle. You're saying that there's 15 people different that belong to A than B. And these are the 15 people that belong to both. So don't start out trying to do a union statement by just adding the gross numbers together. Find the individual pieces. You got to break them down to the individual chunks of the problem. So what happens here is in reality, let me do something here. I'll do this over here, okay? We're going to take the 15 items that are in the left-hand crescent. We're going to take the 15 items that are in the middle, and we're going to take the 35 items that are on the right-hand side, and that's going to give us our total, which we already knew because we had done that addition problem before, and we came up with that value of 65. This actually turns out to be 60. Why'd you let me write 65 there? There's only 60 left over, right?
Yep.
Yes? No? Okay. Second item. Must be in A, but cannot be in B. In other words, it is only in circle A and not part of any other circle, which we already found, right? 15. Using that as a guide, what's the number 3? How would you read number 3?
Not in A, but in B.
For me, it's easier to start with a positive thing first, what I do have, and then start talking about what I need to take away from that. If you talk about what I don't have, it doesn't make sense to me because I don't have it. I don't have a frame of reference to take anything away from. Must be in B. It cannot be in A. In other words, it's B only. So have we already figured out that that's 35? And now how would you read the bottom one?
Must be 15.
It's not in A, and it's not in B. So it means it cannot be anywhere in the circles, right? Cannot be inside either circle A or circle B. So that's another way of saying it has to be outside the circles. And then we already find out that that was going to give us a value of 65. 60. So this was 65 here, and this down here is 60. Okay, so I've made 2 mistakes for the day. There are other ways you could do this. But in teaching this class for the last 5 years, in my opinion, the simplest way to do it is to find all of the individual pieces first. The most useful piece of information is what belongs to both of the circles. If you've got 2 circles. If there's more than 2 circles, it gets a little bit more complicated. But yeah, you're going to see those too. Make sense? Take away the symbol.